Yeah, it's moving now.
Okay, perfect. Thank you, everyone. And okay, so we talked about why zero trust security. I think the main idea here is um, we are more at risk of getting our devices compromised. And if we have a device compromised, we want to contain it very, very quickly. So, what would be our approach when we know there's a device that's infected? And that's exactly the control that we want to put in our architecture. And that's what we mean by zero trust. When we talk about network security, we are talking about the flows to our VMs, to our workloads. And when we talk about flows, we talk about packets, we talk about the traffic that comes to it. So when we talk about network security, how to make sure only legitimate traffic reaches our workloads and we protect ourselves from the threats through this traffic. Um, Three main pillars for network security. Segmentation. Segmentation is the example I took, like a VM is compromised. Now, the next thing you see is where all can this VM talk? In a typically trusted internal network, this VM can reach out to many places, probably the entire internal network. But then when we know it is infected, how do we uh, make sure that this does not go and infect the entire network? And that's where segmentation comes in. Limit the access that this VM has so we know who all it talked to and we can contain the threat very, very quickly. The second part is threat protection. We saw how publicly accessible devices have larger threat. So how to identify the threat, how to protect our devices from the threat, and the bottom line is how to keep our applications up and running and accessible. That's what threat protection does. And we will look at how to include this protection in our architecture. And the last thing is encryption. Remember, we can try everything, but when there is a threat, a hacker can sniff the packets and get the information that they shouldn't be getting. To prevent that, we always encrypt the traffic. Encryption should be end to end, from the end client machine to the server they are trying to reach. The reason is hacker could be anyway. While we have many controls in place, we want to make sure that the traffic is encrypted for how much ever time the threat is open. We want to make sure that hacker is not able to read our sensitive data. So best practices, end-to-end encryption, and use controls that enable you to have this end-to-end encryption. So the next thing is, what are the controls available on Azure to help me do that? I will start from the left. For segmentation, we talked about how to restrict access. We will look into network security groups. We will look into private access, where to enable more and more private access versus public access, even though we live in this place where everything has to be accessible publicly. Then we want to look at the protection layer. So we will talk about Azure Firewall, Web Application Firewall, and DDoS protection. All these three help to protect against different types of threat vectors. So the landscape out there is very complex, and we will see how each of this device addresses different types of threats. Now, when we talk about security, security has to be built in layers. So to be able to do defense in depth, we have to have security at different layers. No one solution is do it all, right? As you see here, I will walk from the center. We see, let's say this is a VM that you're running in Azure deployments in your environment. First, we start with network security groups, how to identify where all the VM will talk, and how to restrict access from unwanted devices. Then we deploy a front the VM with an application gateway that has web application firewall protection. Remember, the biggest thing about security is actually availability and performance, right? So application gateway gives that feature combined with web application gateway helps protect that application traffic for it. And then you can add firewall in front of it along with it because You want to make sure all the threat vectors are identified, right? So web application firewall with firewall do an amazing job of taking care of multiple types of threats. As we move out, we are seeing there is private access availability, there is protection from volumetric, but as you see, all of these are in addition to the other. And all of these solutions build on top of each other to provide you that level of security to make sure your VM is secure and thereby your application is secure. Compared to what we did before, control the routing, control the access, and we will look at some of these solutions now. So let's start with network security group. On the right, you see a diagram where I have a virtual network. When we talk about virtual network, we are saying we're deploying our workloads here. Virtual network by itself is an isolated domain. So whatever you deploy here cannot talk to the outside world and vice versa unless you allow access. But of course, you need to allow access. And that's when network security groups come in. So network security group enables you to have rules like from the internet, allow access to my web servers. My web server should be able to access my app servers. If you see the two subnets that I have, and then subnets provide another layer of segmentation, network security groups attached to the subnet. As you see below, these are the rules. So rules are where I explicitly say what access and to who. So for example, my first line is from the internet. So I'm having an action of allow. I have a source of internet. So anyone from the internet can access my VMs in the subnet 10.1.1.0/24. So that would be my web VMs here. And then the port that I'm opening is 443, and that's the only traffic I'm allowing. That's the action I'm putting. And it's important to restrict ports, right? Your application does not need to be accessible on all the ports, and that's the biggest vulnerability on a VM is when all the ports are open. But this is where network security groups come in. They can be attached at a subnet level. That means all the VMs on this subnet 10.1.1.0/24 are protected. They can also be attached at a network interface level. So this enables microsegmentation. What we mean by microsegmentation is you attach an application security group like a tag. So when I say web on this diagram, that's my application security group. So when I add that application security group, I can reference that ASG or application security group in my source and destination. So if I look at the second line, I'm saying from source web to source app. And web and app are all the VMs that have application security group enabled. So in this case, only the VM below on subnet 10.1.1.0 can talk to the VM below with the app tag on 10.1.2.0 can talk to each other, but not to the other VMs that are not tagged, right? So that is micro-segmentation. Even within a subnet, you are controlling who can talk and where. And then being on Azure, there is an easy way to refer PaaS services. If you know PaaS services are a lot of IP addresses, then we can use service tags. Each service tag gives the ability to address an entire PaaS service, like storage, for example. Storage will have a lot of public IPs, and then they keep changing. So instead of having to put that list of public IPs, maintain whenever they change, you just use a service tag storage. I actually don't have it in my example here, but like you have a destination virtual network, you could say storage when I want my VMs to access it. Okay, so here is an example of out-the-box network security groups that come when you apply an NSG or network security group. So as you see here, there are inbound security rules and outbound security rules. NSGs are stateful for your flows, by the way, but by default, as you look at the outbound security rules, Pretty much everything is allowed. So first rule, if you look at the outbound security rules, the lower section, my first rule is source virtual network, destination virtual network, meaning all IPs, all subnets within my virtual network can talk to each other. The action is allow. All VMs in my virtual network can talk to internet, and then internet would be like a service tag again. And then the action is allowed. So essentially, I'm saying everything outbound is allowed. And then there is a default deny. So default outbound is allowed. Inbound, if you look at the inbound rules, within the virtual network, all communication is allowed, but anything else is denied. So inbound, everything is denied from the outside environment by default. And this default behavior you need to keep in mind because then you put your rules accordingly. So inbound, we definitely need to allow. So there is a field called priority. The larger the number, the higher, lower the priority. So if I want to allow web access, right? So I would add a rule priority 1000, source, my subnet 10110, source internet, my destination 10110, tying the previous diagram, and then I allow that traffic. But sometimes you also, or in today's environment with zero trust, you also want to restrict outbound access. And that's where you want to identify what flows your applications need, and then put a higher priority or lower number rules in front of the outbound security rules that are already there. So hope that helps with the network security group. Now, and what happened with the segmentation there, right? We restricted where the VM can talk and where not. So in the case of an attack, we know, okay, this VM was able to talk to all the app servers or these specific app servers. Now we know what environment to contain versus pretty much every VM. Private link. Now there is a use case. Best practice is always have only private IP, do not have a public IP wherever possible with your environment, right, with your workloads. But now we are talking about Azure PaaS services. All PaaS services are always accessible over the public IP. So for that, the VM will need a public IP to go out. So how do we address this solution? Typically, we add firewall rules. So you use those NSGs to restrict. But then you also need firewall rules on your PaaS service because now you have sensitive information there. And then there are different environments that will need to access these PaaS service. So it is a bit cumbersome. And the bottom line, it does need a public IP address on the VM. But we want to solve that. And that's what Private Link does. Private Link actually is a cool technology that provides private access seamlessly with only a few clicks or very little work on our side, and makes that entire PaaS resource privately accessible. So let me just walk through how that works. So I have a storage on the right side, account that I want to access from my workloads. Using Private Link, I create a private endpoint. So if you see that 10.0.0.1, that's a private endpoint, which is actually a network interface that is deployed into your virtual network. So when it is deployed in a virtual network, it gets an IP from the virtual network address range. So this would be a private IP address, right? And then now when the VM wants to talk to the storage account, it will talk from its private IP to the private IP of this network interface. And this private IP under the hood connects to the storage account, right? So you don't have to worry about that green dashed line. That's what Private Link does for you. All you have to do is create a private endpoint for your storage. So VM to a private endpoint connectivity, all private. So if you look at the rules in my NSG, I had that internet access. I don't need to allow. I don't need that VM to access anything from the internet. Similarly, if all your workloads are accessing this privately, you can even close off internet access on the PaaS service because someone is trying to access your storage from the outside. And you have nobody who needs to access from outside because now we have private link. Private link can also be accessed from on-premises environments. So if you have these on-premises connected via express route or VPN, you're providing private connectivity to the virtual network. And then you can access the private endpoint the same way that you did from the VMs, which in turn enables you to access the storage and SQL PaaS services privately. And you can also access it through VNet peering. So typical hub and spoke scenario, put all the private endpoints in the hub network on a subnet, and the spoke VMs can access it. So seamless, you don't have to go on each and every VNet and add controls there. So a very big advantage of private link is data exfiltration protection. Remember how we said now this private endpoint provides private access to your PaaS? That PaaS is actually the very specific account that you want to access, right? So if you look at network service groups or service endpoints that we had, you provide access to the entire storage PaaS service. But then there is a risk of data exfiltration. So with the private endpoint, I am only creating a private endpoint to my specific account. That is my SQL Server resource. So if there's another SQL Server resource, I cannot access it, or the VMs cannot access it. If there's another storage account, you cannot access it. You cannot pull information from one and send to the other. And that's data exfiltration protection. And that's how we secure the PaaS services. But we want to extend this concept. So now let's say you have you have a provider service, right? The provider has this service running as a SaaS service in Azure. For their clients to access it, typically they go over the internet and access it. But if your clients are in Azure, how to enable them to access this service privately, right? That would be even more beneficial. Because bottom line, how to avoid public IP traffic. So for that, all the provider needs to do is take the application, front it with a standard load balancer, and from there you can create a private link service for this, which gives you an alias. And that alias link is what you send to your customers. Customers use that alias link to create the private endpoint like we saw before, and that private endpoint stays in their virtual network. And that's how they can access your service privately. Again, from customers, if you're working with customers, you can ask the providers to provide a private link service and help configure private endpoint to these SaaS services, right? So whenever you have access from on-premises, I think the slide came in between, but I'll just address it. Whenever you have access from on-premises, one thing to keep in mind is you want to be able to resolve, so this is for the PaaS services, you want to be able to resolve these PaaS services to their private IP, in which case you will have created a private DNS zone for your service when you create private link. For on-premises service to access this, they need a custom DNS in the VNet, but you also have a DNS resolver now. So you can use that to forward all your requests for those services to that DNS resolver in Azure and access from there. So I want to come back to the private link service. So this is the diagram of what I access. On the right, there is my applications running. This is the provider network. This is their SaaS environment. They run their applications with a standard load balancer and create a private link service. Now on the consumer side, you create a private endpoint to that private link service, and the connectivity is established. Keep in mind, there is no VNet peering. So there's consumer VNet, there is provider VNet. No connectivity, just the private endpoint. So what this enables me to do is I don't have to worry about overlapping IP addresses, right? That was the biggest problem. Whenever you have customers consuming your service, you have to peer to them to access privately. But now there is the whole issue of overlapping IP addresses. With Private Link, there's no peering. You can have overlapping IP addresses. As you see here, both provider and consumer are using 10.0.10 subnet, but the consumer is only accessing the private endpoint in their VNet. And it's the Private Link magic that's working in between that's taking care of this connectivity for you. So very, very simplified and very secure. And it meets our goal of allowing only private communication. So just to recap the flows, excuse me. First step, fronted with a load balancer. When you create a private link service, you get an alias or a service ID, and you can see it in the portal what it is. You go ahead and share with the consumer. When the consumer creates that private endpoint, like we discussed, you will see it that there is a request for this customer to access your service. So it's not like anybody can take your alias and create a private endpoint and start accessing it. You have that control where you see the request and it is not approved until you approve it. So you look at it, is this known customer? And if it is, you go ahead and approve that connection. If it was from some random user who is trying to connect to your service, you get to reject it. So now there is complete control on your side, but ease of access from the consumer side. And once you approve it, that's when the consumer is able to privately access your service. That's it. So let's take a look at how this looks. I have an example here. You go to portal.azure.com and just search for private link. Make sure to select private link, right? And that'll bring you to this page. Here I can create a private endpoint or I can create a private link service. So I'll just walk through the steps of creating an endpoint real quick. You have, keeping tabs on time too, you get to select your resource group, the standard. I'll just give a name to...
Pinal, can you just zoom on your browser, please?
Yeah, I will. Thank you for reminding me. These get very small. Okay, so is it better now?
Much better, thank you.
Okay, yeah, and then you give a name, and as you see here, it'll create a network interface for you and provide a region, select next. Here for the connection method, you say, connect to an Azure resource in my directory. This enables you to select your resource. So if it is in your directory, you can just select this, right? And then from here, you will select an account, your storage account. Remember, data exfiltration protection, only this account. The private endpoint will be able to access only this account. So even if I have others, or someone has their own personal, that's not going to be accessible. And then because it's storage, I will select blob or table or queue. I will select blob, right? While I am here, and then, okay, so while I'm here, let me just address this. If you're creating a private link service, you will have an alias generated. Then to the customer to create the private endpoint, this is where they would give their alias. And then you won't have these fields, you'll just have a field for alias. And then the private endpoint needs to be deployed in a VNet on a subnet. So here you will select the VNet that you want to deploy in, and then you will select the subnet. I'm just going to keep the defaults, or let's change it, subnet 1. And then you have an option to either give static IP or let it dynamically choose. So for private endpoint, you need to enable private DNS, or you need to configure private DNS. As you see here, there is a private DNS zone that will be configured, private link.blob, private link blob core windows.net. and you want to say yes, it just simplifies. We have private DNS zone that is automatically created for you. If you have your own, then you have to configure. But for here, I will just do that. And then that's all I need to do. So I already have a private endpoint created. So I'm going to X out of this. And we will look at the private endpoint that I have. So this is the one that I created. So if we go through all the steps, I have created this for a storage account, storage one account. And you see here, it is deployed in one subnet, VNet PE. And this is one way, and a best practice way to deploy is put all your private endpoints, because you have multiple services and larger environments. So just make one VNet for all the private endpoints. And as we go through firewall, etc., you know how you can provide more controls there. But if you put it in one VNet, you can peer it to the hub and have all the traffic route through all other spoke VNets access it through there. If you don't have too many private endpoints, you can create a subnet in the hub and put all the endpoints on that one hub, ease of management and ease of access. You can always put it in any VNet, but if you have a large environment, this is how it helps out better. So this is deployed on a subnet in a VNet, and there is a NIC, and it gives me which resource I am creating it for. So I just wanted to check the IP configuration. So if you go to the NIC, you see the address that it received, right? So it is 10.150.04. That's the IP for this service. So if I go back here and check the DNS configuration, as you see here, it has DNS connection. I want to look at the private link, private DNS as it shows up here. As you see here, this is my private DNS zone. I have a record created for storage account storage 1 VNL, and I have the IP address, and this is for my private DNS zone, right? So now let's see if we can access it. It's early in the morning, and all the VMs were down, so just bringing it up. So please keep some patience if it's taking time to load. But before that, I can also try to access this from my laptop. So so this is my laptop command prompt from my laptop screen. I will do an NS lookup for storage one VNL dot the hard to talk and type, but I gave my storage account URL. So when you access this private endpoint, you still use the same public URL, right? Even though we have a private DNS zone, I'm going to access. So this is publicly accessible right now. So I'm going to do an NS lookup on it. And it didn't like something. Okay, you know, I'm on my work network, so I'm on site. So let's just look at it from here. So here I have a VM in the hub. The IP is 10.0.1.4, and I'm going to try to access the same .core.windows.net, the same storage account. And if you see here, this is the public URL, but it is connected, it is translating to the private IP address. So ideally from my laptop, I think I have a VPN, so it did not work, but I would have seen a public IP, right? So anywhere from the public internet, this would resolve to a public IP. But because this is in my VM and I have created the private endpoint, it resolves to the private IP. As you see here, this storage, so the path that it took is this storage account when you gave the VM went to its DNS server, the DNS server is Azure DNS server, or if you have your own DNS server, you forward it to Azure DNS server. Azure DNS server says, okay, I have a CNAME configured for this, so goes to the private DNS zone for that. And then this is my CNAME for it, right? Storage 1.0.privatelink.blog core Windows Net. So even though I gave the public IP URL, this is how it translates, and that's how it got the private IP. And that's how we know that all the communication is private. Okay, that's all. I have a little bit time, so maybe I will go to portal.azure.com and take a look at the network security groups just to show you how it looks in the portal. So when you want to look at network security groups or create network security groups, you go search for network security groups. It brings you here. If you don't have any, you create one. Let me see if I can just walk through that. And then RG Lab. So, the reason I'm walking through the configuration is just so you know, I know we don't have, this is not hands-on labs right now, but this will help you to understand how to go about configuring, right? So I'll just say NSG1, give it a region, and that's it. I go next and I create it. So I will just pull one that I have created. And if you look at it, it will show you the rules here. It gives you the information at a high level. It also tells you 3 inbound rules created. You see here, these are the defaults. The 64,000 are the defaults that we saw before. So by default, virtual network communication is enabled. But I want specific IPs to be available right now because this is the demo and I have more environments. I open 10/8 range, but you can go granularly, 10.1.1.0. /24 can talk to 10.1.2.0/24 and so on. I just have a larger environment, and for demo, we want to make sure we access it. But this one I added with a lower priority with 100. So first, this rule with priority 100 gets executed. Then 2700 rule, where I'm giving specific IPs to access from outside, and then to outside world, and then so on. To create a rule, you click on the settings on the left side, you go to inbound security rules, and you can add a rule. So I can add something like source. So here you can give IP address, service tag, application security groups. If I had created application security group, I will say this, and the example of web, for example, the VM has the application security group. I could access it here. I will give very, very simple access here, 10.1.1.0/24. Source port range, source should be any. Destination, here I can say service tag. And here I can say storage, for example. Can also go granular to storage, West US2, for example. Let's just say storage. And then the ports, here I can say which ports. Let's say I only want communication on HTTPS. So this is where I restrict the ports that it can access. But let's say I had some specific ports for mine, or maybe I wanted to allow, so this is not best practice, this is just for demo. I had more ports for my application, right? If I had my own application subnet here, then I can say custom and provide custom ports. But here I will just say HTTPS. When you say custom ports, you can select, is it TCP, UDP, ICMP, or all. And then the action, I can say deny for specific traffic. So if you see offending traffic, for example, that's what you say deny. If you know this is a restricted, more sensitive environment, then you deny traffic from many places. So this is where the deny action comes in. If you have a deny, make sure it is placed in priority above any allow rules. And that's it. Then I give it a name. My restrictive rule and no space. Right? So this is given name, and then you just go ahead and add it. I'm just going to add it. It's not going to break anything. I just want to make sure I don't break any of the demos. But that's it. That's what you do to add a security group. Now, how do I, so now that I created this group, you need to attach it to your subnet. Without it, it's not getting any benefit. It's not being used. So here I want to attach it. I have a hub VNet. So this is my hub VNet hub 1. And I have attached it to this these subnets here. So any subnet showing here is where it is attached. If I want to attach to a new subnet, for example, I would just go ahead and add this subnet. So it shows here that I have already attached it to all the subnet. Otherwise, it will ask you to, I just have it on all the subnets. Okay, so that's how you attach it. You can also attach it at a network interface level. So here you can give the network interfaces of a VM that you want to attach it to. The only thing, and that's all you do, you click it and you save it, and that's it. The only thing to keep in mind is if you have an NSG on the subnet, that will be executed first for inbound, and then the NSG on the interface, and then you have to check rules on both sides. So make sure it's simple enough to be able to manage in live environments, right? So if you have allowed the traffic on the interface, but on the subnet it was denied, then your traffic is denied, and then troubleshooting is very different because you have different NSGs on different places. So hope that helps, and that's what I have for the first section.